Okay, in section 2 of the Sasquatch challenge, we're getting into some different processes. What we want to know is first, how many of the Bigfoot sightings were within 1 kilometer of a city? And for an exercise like this, it makes good sense to just ask a simple question like that and pick a random, distance value. But remember that the cities that we're dealing with are points. And, what does that actually mean if you have a city that's representing something that has an actual value or area value? So if we add a different base map here, little towns like West Haven compared to something like Ogden is already very different. And we don't always know if the star is being placed right in the middle of the city. It's probably also a given that not every single city in the United States is being accounted for. And representing something with area as a point is just going to be a problem to start with, unless you're just making a visualization. But calculating distances away from something is going to be awkward if you're not using a polygon that maps the municipal boundary. Okay, so let's dig into that second part. How many of the sightings are within 1 kilometer of a city? And for me, the easiest way to do that would be a select by location. So I would head up here, and my selecting cities are going to, selecting features are going to be my cities. And the input feature, the thing that I want to be choosing so I can get a count of them, are the Bigfoot sightings. I don't want this selection. I don't know what that is. There we go. Okay, and then we want it to be within 1 kilometer of a city point and within a distance. So I'm going to apply that and zoom out a little bit. And let's turn on our Bigfoots. Okay, so let's open this attribute table and see if anything happened. It looks like we selected 310 out of 3,272 points are within 1 kilometer of a city. We can zoom in and verify. Okay, going back over to our questions, which county has the highest number of sightings? So how are we going to figure out how many sightings are within each county? There's a couple different ways to do this. You could run an intersect between the county polygons and the sightings. You could do a spatial join, which is going to join the count of the sighting locations that are within the spatial area of the polygon. You can use a tool called Summarize Within, which is kind of like a beefed up version of spatial join. It gives you some more summary statistics options. My favorite way to do that is to do a spatial join. It's straightforward and I think easy to follow. I'm going to start there. First, make sure you're always clearing your selection, because remember, tools only work on selected features. All right, so a spatial join. Okay. This one's a little bit harder to figure out, and even the information dots don't help very much. But the target feature is the thing that you want to output. It's the layer that you want to look in the attribute table of to find the count field. If we were to join the counties to the sightings, we would get our output feature class would be points, and each point would say it has 1 county associated with it. And that's not what we want. We want to know how many sightings are associated with each county. So our target, the thing we're joining to, is going to be our county data set. The join features are going to be the Bigfoot sightings. You should give this a good name to keep track. I'm going to rush through it. Intersecting works, and we can leave the rest of it. Okay, we got out a new polygon feature class that looks just like the old one, but the difference is in the attribute table. So in the attribute table, you can see there's a join count field now. So for every single county, this is a record of how many Bigfoot sightings happened within it. And we could test that. We could select, let's select this county. that happens to be Clear Creek County, and it says that we have 1 point and we have 1 point. You can't always rely on this because sometimes the points are stacked so close on top of one another that you can't actually see that there's 2 points there. Sometimes, you know, the coordinates might be truncated, might not have the significant digits to get a precise location. So don't rely on being able to count them visually. But anyway, that's what that is. So the join count field is how many we have per county. So what was the question? The question was, which county has the highest number of sightings? So all we're going to do here is just sort this. And it looks like the county with the most raw count of sightings is Pierce County, Washington, coming in at 50. So that's how we did that. The next one is asking who had more sightings, Oregon or Ohio, and how many sightings. There's probably a slick way to do this, but I went kind of the grunge way. Select by attributes. This is clear. So I want to do, yep, that works, where the state is equal to Oregon, and apply that. We've got 36 records down here. If you just show those, then we can use the statistics feature. Move that out of the way. Go back to our join count, right click on it, and let's hit statistics. This opens a new panel that summarizes the statistics of the join count field for us. It gives us an average number per county. The selection is Oregon, and the data set is all of them all together. So you can already see the mean sightings per county are much higher for just Oregon than they are for the whole data set. But down here is the sum. So Oregon has 166 sightings, and then we can repeat this where the state is equal to, I'm going to clear my selection, and I'm going to redo this where the state is equal to Ohio. And hit OK. And we have 88 counties. I'm going to do the same thing. This works because I'm using just the selected features. It might work anyway. Sorting it doesn't work if you are looking at the whole data set, of course. But this would probably work just as well if you had all of them showing. No, that is not what I wanted to do. I wanted the statistics. Same thing over here. A lower average per county, but a higher total. So 214 sightings in Ohio compared to 166 in Oregon. All right, and then what do we have left to answer here? Which county has the highest density of sightings? So now what we have to do is calculate the density of sightings. So not population, but density of sightings. So it's kind of the same thing as in the first part. We're going to add a new field. Let's clear our selection here. Add a field. We'll call it site density. Make it float. Save that. All right, and then scroll over to that new field and do a field calculation in which we want our, oops, that didn't quite work. All right, try that again. Right, site density needs to equal join count. It's the number of sightings per unit area. I'm going to use the hectare again, and I forgot my divider. There we go. Okay, then let's sort this. And it looks like White County, Georgia, named after a legislator who's responsible for making that county a county. So that is our highest density for a county, which is kind of interesting. That's not at all what I would expect. So we could go back to the map. We can select this record and zoom to it. And there are quite a few sightings. It's not a very big area. Oh, where are we? Huh. So let's actually take a look at the imagery again. Let's turn this thing off. Just make sure we're in a forested area, I guess, more than anything else. See what kind of, oh, we're right in the Chattanooga National Forest. So that's it for section 2.